What's up? We're back. This is going to be much shorter. Delta loops. I had a parasitic delta loop array, reversible, up for years and years, and I got sick and tired of dealing with maintenance. This was back in February, so I tore everything down. And I'm back to a single element. So I just got a single element up the other day, and I'm waiting for some LMR 400, which should be here sometime this evening. It's about 5 o'clock. And I'm going to patch that in. It's about 150 feet to a matching stub. So I'm going to go over really quick what it looks like. So let me get over to the other screen. Okay, I'm going to go over the Delta stuff really quick. I did I think I have multiple videos up on this, so I'm not going to spend too much time. Just type in Delta Loop on my channel, and all the videos with it regarding Delta Loops will come up. Okay, let's get over here. So what we got, these are all the different orientations and the types of feed orientations and placement of feed points for a vertically hung Delta Loop. So we have an apex up, which means this is suspended from the trees across the top here. This is apex up, fed from the top apex. That's horizontal, moderately high angle of radiation. B is apex up, fed from the middle of the bottom, which is high angle of radiation, horizontally polarized. C, which is what I have, is an apex down, apex feed. So the two top corners are suspended in the trees, and the antenna is about 80 feet up in the air. It's way up there. Never had one of these that high before. So that's flying by. It's in the top, literally the top of a huge ash tree and a poplar. Not the poplar. Poplar is about 115 feet high. So she's down a ways from the poplar, but I didn't want it crooked, so I set it level. Okay, that is C, horizontally polarized, moderately high angle of radiation. Works well here in the valley where I live. D is more of a DX antenna. That's apex up. Apex is the point. Apex up, fed from the bottom corner. That's low angle of radiation. All right. So mine is C, apex down, apex feed. Moderately high, horizontally polarized. All right. So let's get over here to the VNA. It's a little high. I didn't want it this high, but that's okay. It's around 7.225. Which is fine because I spend most of my time from 7140 to 7300, right? Best return loss is almost 19 dB, minus 19 dB return. That is excellent for a single element loop. Very good. And that's at 7.228 megahertz. So, how did I match it? Over a couple things here. So the Delta Loop, again, is oriented like this. Feed point is here. Cord goes up to the trees. All right. To match a Delta, this is a monoband. This is a monoband loop. So I've done this so many times. What I'm using is RG6 quad shield, RG6U quad shield. It's a 75 ohm coax. So what you want to do is you want to take your wavelength. So I have 140 feet of wire divided by 4 equals so that'll give you the 1/4 wavelength, which works out to be 35 feet. Okay? Can't stop there. Take your 75 ohm coax. You're going to need to know the velocity factor. So what you do is you take your 1/4 wavelength times VF. So you need to know, so this is the 1/4 wavelength right here, 35 feet, and you need to know the velocity factor of the coax you're using. Okay? Mine, RG6 quad shield, is 0.66. You can usually find it online, so that's the VF. So when you multiply 35, so you multiply the 1/4 wavelength times 0.66 equals 23.1 feet. That's the stub. You need to cut 1/4 of the 75 ohm coax with that velocity factor. You need to cut that to 23.1 feet. So what I did was you direct feed it. That's the stub. Direct feed it 23.1 feet. 75 ohm at 0.66 VF. And then that comes to a barrel, and LMR 400 or whatever, 50 ohm, 2 shack. Simple as that. Okay? So that's all it is. Simple as that. I have 6 ferrite beads. At the feed point, which shuts down. All you need is about 5 or 6. That's all you need. And that will shut down any common mode coming in, trying to sneak back in. Measure the coax and then order your beads accordingly for the inner diameter of the bead. Or you can just spin up some turns of coax, which I don't like doing. I just put the beads on. It's so much easier. Just snap them on, you're off and running. That's basically it. And I will be testing this weekend. We have the Maryland QSO party, so I am looking forward to that. That's basically it, guys. So that's the 40-meter Delta. That's the VNA. She's flying about 80 feet. Way up there, Johnson. Oriented northeast, southwest. And should be absolutely zero maintenance. So looking forward to give this a whirl. It can't compete with the 2-element. There's no way it can compete with that, but I did work. Who did I work last night? Oh, I worked a couple POTAs or something like that and got in there, no problem. No problem. So it should work well. 7-3. Let me check the chat quick, see if anybody's back. K2 ICC. BNC to 239. Nah, I'm all 239. BNC's better. K2 ICC. But I just barrel everything. So I put a 259 onto the 75 ohm coax, and that directly connects to the LMR 400. I've got multiple connections out there. And Mini 8, 100 feet of Mini 8 going, RG8X going up to the antenna. So I've got the 75 ohm stub, the Mini 8 right now, all barreled, and then that's barreled to a piece of RG8, which is about 15, 20 feet long, and that comes into the switch. So I can get rid of all that once the coax arrives, hopefully tonight sometime, and I'll be out there in the dark putting it on. Get that into the switch in the southeast corner, and that goes all the way to the matching stub up by the antenna. So there you go, man. All right. That's it, guys. We'll catch you this weekend. Hopefully the bands, boy, I hope we don't get smoked, because the Maryland QSO party, that's a good one. If anybody's around. If nobody's around, I'm going to call CQ for Maryland. So we'll be in here throwing some RF into the ionosphere. We'll see y'all later. 7-3. Don't forget to hit the like button, subscribe, help spread the algorithm, and I appreciate everybody watching over the years.